In this video, we will try to see how to create a root file system for a BusyBox. So for this, we need three utilities. You need to download BusyBox and compile it, and we need mkfs utility and qemu-img to create the image. So make sure your system already has a mkfs installed and qemu-img installed. Now we will see how to create a image using a BusyBox. So this is a command to download the BusyBox version. I have downloaded 1.37. You can download any version. You can go to busybox.net and you can download. So here I'm doing wget, and then you need to untar it. So this is untarred now. Go inside that folder, and then you need to do make def config, that is default config. So whatever config they have set default, it will be enabled. If you don't want to do this, you can do make menu config and configure it yourself. While compiling, we need to enable that. So go to make menu config. Here you have to go to settings. Inside that, we'll have a build option. Then it should be here. Debug options. Build options. Inside build options, you have a static library. Enable it and then give exit, save. Now you have to compile it with this option. And then install. X is equal to static. This is a, so it will take some time to install. Compile. Once it is compiling, then we will see how to create a root file system and copy this BusyBox into it. So now compilation is done. Now you can see ls. So this is the BusyBox. You can see file BusyBox. You can even run it. So BusyBox ls pwd, all the commands you can see. So now compilation is done. Now we need to install. Before installing, you need to create a root file system. So for that, you need to create an image. I have already created, but I'll still create and show you. So I'm coming here and just give this command. What this will do is qemu-img. It will create a qemu-img with a file name of rootfs and with 512 MB. You'll see. So you can see format, size. You can just give ls. You can see the file. It will be data. So because it does not have any file system. So this is the first step, using qemu-img create. The next step is you need to create a file system for that. So there are different file systems. See mkfs, est, like this. So now I am trying to create ext4 file system. So rootfs, whatever name you have given. So now this data should be changed to ext4. We'll see. So it has created a block. Now you can see it has created a ext4 file system. So 64-bit, huge, like this, everything you can see. It is a Linux version 1.0, the first file system. So we have created a rootfs, but this will be empty. We need to mount and add required files to it to make it bootable. So we will see that step. So I'm creating a folder inside this to mount this. So mkdir and this, and you go inside this folder and see, you will not have any content. Now come out. We are going to mount this file. So command is mount -o loop. Loop is for a file, right? It's not a device, so that's why loop. You have to allow permission of read and write, give the file image and the folder on which you need to mount. So now you see cd local s, see task found. So it has created a mounted it now here. Next you have to copy it inside this. So now you see there is no content. So what you have to do, go inside the busy box now. We have compiled. Now we need to copy this inside the folder. Okay, here inside sample busy box you have local, sorry, inside this you have local mount. So you need to give this path, busy box sample local mount. So here this path, config path should be like this: home ubuntu busybox sample local and install. So we'll see. So ls content is nothing, come outside, go to busybox where you have compiled, make sure you are in this path, and then give make config underscore prefix, that is the path inside the rootfs which we have mounted is empty, so that we are going to install. So I can open one parallelly so that you can see. Ubuntu busybox. Okay. So this sample. I'm just having ls. So now nothing is there. Once we start installing, here you will be able to see the files. See, bin, src, everything is installed. So like this is the command which has copied. You can see it is copying. That's all. Now move to this path. cd. Okay. So this is the busy box image, everything we have copied here. Now we need to make some changes so that this is bootable. So how to make it? So you need to create directories, devices. So you can see there is no device files. So you can do mkdir and move inside that folder. So now here you need to create a device, mkdev hyphen generic. So this will create all the TTY, PS, all the devices. RAM, console, everything it will create. It will take some time. Your local mount. See, you can start seeing the device. See, this much devices it has created. We'll wait until the command is completed. Now it has created. You can see here dev. So this is one step. Then come out of this, and in this folder you need to create other etc, proc and sys. So these are all to get the kernel parameters, etc to have the bootloader path, mounting path, everything. So come here. You see here you don't have etc, proc and sys. Just create these two folders. Now go inside etc and you need to add this path, this file. So this is to create a file with EOT. I'm just adding like this. Since we have created ext4 file system, I'm adding like this. So ubd is the driver which we are using. So we are giving dev ubd0. So make sure the dev creates this. If it is not there, then it will not boot up. So this is the fs we have created in etc. Then we need to create an init inside this folder and move inside the directory and then create this file. What this will do is say welcome to busybox, and it will mount all the file system required. So rc, this is an rc file. Just change the permission. And then come back to etc, and here we have to create add this init rc to this init tab. Sysinit is while booting we need to create any device required, so I am giving mkmdev.is. So come outside, come to etc, and here you need to create this. So these three folders, now these three files are created inside etc. And now that's it, we are mostly done. Now we need to come out and unmount it. Okay. So now if you see this local mount, you will not have any content. So again you can mount using this command. That's all. If you want to unmount, like this. So now we have created a file system. You can see file qemu-img, which has these contents. Then to reboot it, you need to use this command. Sorry, to start, you need to use this command. Up to this, these are the steps to create a root FS. In other videos, we'll see how to compile a Linux kernel in a UML image to boot this, and then we'll see how to connect it to the internet and net create a root file system. I'll just recap it. So you need to download the VisiBox by using write command and extract it. Use make dev config and use only static build, don't do dynamic build. Then you create a image, qemu-img, then create the file system for that, and try to create a folder and mount it into that. Then copy the file system, copy inside the file system. What all VisiBox you have compiled, everything you copy inside the file system. Then create a dev file folder and create all the devices required, all the generic devices required. Then create etc proc and sys file system. Inside etc, fs tab is used to mount all the devices. So this file you have to copy, and you have to create a init and inside that rc file. This will say the welcome message and mount the devices. And then init tab, you need to call this rc file, this one, and you need to spawn it with the bin sh. So these are the steps used to create a root file system. In other video, we'll see how to compile the Linux and reboot using boot with this VisiBox. Thank you.